welcome everybody. This will be a talk about an open source approach about multi-tenant label-based access control. My name is Constantin Winkler. I'm a DevOps engineer and 21 years young. I started 1.5 years ago at Gepardec and joined primarily the Gepardec Run team, which is our cloud offering. Let's do a short history to OpenShift. This is OpenShift 4.10. Specifically, it's the monitoring stack. This is OpenShift 4.11. Can you spot the difference? Once again, 4.10 and 4.11. There's something missing, and it's Grafana. Effectively, Red Hat threw away Grafana and, in contrary, offered us the metrics in the OpenShift console, which are feature-rich, but they're missing something crucial. And that is user customizable dashboards. And this is powerful because you can have application-specific dashboards that show you immediately what is wrong with your application. And right now, you cannot do that in OpenShift. So we took the advice from Red Hat to DIY, or commonly known by YAML engineers as deploy it yourself, and took Grafana and pointed it to the Prometheus. Technically, it's Thanos in OpenShift, that is inside of OpenShift. We didn't want to give everyone access to Grafana, so we put a proxy in front of it. And for most applications, the OAuth 2 proxy is enough. We faced an issue where the OAuth 2 proxy wouldn't work with the Grafana group names. And therefore, so here we see how Grafana maps the groups. So we wanted to have Gepardec Run admins with Grafana admin, developers should be editors, and everyone else should be viewers. So we switched out the OAuth 2 proxy for Keycloak. Done, right? I mean, everything works. Well, not so fast. If you do that, you give basically everyone access to all of your metric information in your OpenShift cluster, which, I mean, if you live dangerously, has some spice to it. But everyone can, for example, search for the alerts. And especially if you have multiple customers on a cluster, seeing each other alerts from another customer is maybe not the best idea. So with this solution, we effectively reduced our security to this. But Grafana offers something to help you with that, and that is label-based access control. But you have to insert some coins to get this wonderful capability. And the question now is, what is LBAC? Well, it stands for label-based access control. And I will give you a bit of a deep dive how it works based on a Prometheus query. So we can see here a normal metric that is in Prometheus. It is the currently allocated bytes from a Go application. So this is a metric name. But there will be probably many Go applications in your cluster, so you kind of want to specify which application you want to look at. And you do that with a label selector. And the label selector are the things inside of the brackets. And you probably also need a label. So it's a key value store with the key container and value Multena. And you also need an operator. For example, the match operator or the equal operator. And this will be called the label matcher. So to make queries sent by Grafana now secure, we just append another label or insert it. For example, namespace tenant1. So the user can now only see their information in the tenant1 namespace. And there are some quick examples. Up is also a metric, gets just appended with the namespace. This is the example we already had, that it has container and namespace. But what happens if user 1 tries to query something from another tenant? Well, it should obviously return an error. And OpenShift itself also has that capability with the prom label proxy. It is in the monitoring stack, and we wanted to use that. And a potential solution with that could look like that you set up your Grafana data sources with an HTTP header or a URL query. You can have multiple ways how to get the prom label proxy to know which labels you want to enforce. And you give the prom label proxy the label, and you give them the metric, and the prom label proxy will give you the LBAC version of that query. You could configure that in your data source. You put the tenant here, and the value, but we've effectively gained nothing, because we now have two data sources again that every viewer in the cluster or in Grafana can see. So we made a full round trip. So our first iteration was to simply take the request we get, look up which user it is, look up in a label provider which labels they're allowed to see, append, and that can be either from a YAML file, most likely your config map, which has this data structure. You have as a key the username or the group, and as a value your namespaces or labels, or from a MySQL database, because we initially developed this proxy with the partner Upper IT, and they represent their permission system in a database, specifically a MySQL database. So Multena now looks up which labels the user is allowed to see, puts it into the header, sends it against the prom label proxy. The prom label proxy inserts the namespace, and you're done. Well, not so fast. We have multiple namespaces, and for a very long time, this operator was a big challenge for us. Specifically, you can query multiple namespaces with this operator. And the prom label proxy didn't support it for nearly 2 years. There was an open PR for it and a fork, but it didn't get merged. So we forked the fork and deployed the fork and had a modified prom label proxy, which now supported the namespace with multiple labels, for example, dev and QA, which can be something very interesting because you can compare between your production and your QA cluster how the CPU consumption is, for example. So you immediately know when there's a new feature that the CPU usage spikes. We put it again into the prom label proxy, and the prom label proxy will use the same query because it was already the healthy query. But what happens if we try to query something that is not in our permission? Well, here we have prod, and we still are only allowed to see QA. Well, we forwarded it to prom label proxy, and the prom label proxy will give us an error with unallowed label. T1 prod is not in your allowed label list. And that is how the first iteration of Multena worked and it was fine for metrics. But in 4.11, OpenShift not only changed or threw away Grafana, they also got rid of the Elk stack. So we had no Kibana anymore. It is now in the OpenShift console. And they introduced therefore Vector and Grafana Loki, which is quite nice because, I mean, I like things written in Rust, especially as Vector is written in Rust. And Grafana Loki is one of the best log search engines you can have, in my personal opinion. And yeah, we got the OpenShift console logs. We also got the aggregated logs in pods, for example, so we can see multiple logs from the complete deployment, which is very helpful if you have like 200 microservices running at the same time, scaled. But you're still missing the user customizable dashboards. So we started to develop this into Multena. And after a long research, we found the Observatorium project. And they're doing something similar. They're building a gateway where you can push and retrieve your observability data in a multi-tenant way. But the funny thing is that they use the same way the prom label proxy parses and enforces the queries with a YAC file. This expression .y stands for yet another compiler. So they're effectively making a complete parser with an abstract syntax tree. And I used Observatorium as a code dependency, pulled it into Multena, and just went through the nodes and searched for every label selector that contains bad queries. And this is how we achieved Multena with Prometheus and Loki. And in the past weeks, we got a PR from DeepL, if you're maybe familiar, and they were very curious about tempo. And we think about supporting tempo in the future, and also not disabling, but like removing the code dependencies on Observatorium and prom label proxy. But how does Multena know which user is which user? Because in which request form would you get it? Well, as I've said earlier, we have a keycloak in front of it, and Grafana has a nice feature, which is the forward OAuth identity option. So we effectively get a JSON Web Key set, which is a signed JWT. And with a signed JWT, you can retrieve the certificate and can check if the user is the correct user. And that is how we achieved super secure multi-tenancy. And the last thing I'm going to talk about is the Multena RBAC collector, because if you can remember, we had this format for our labels, and you don't really want to write that per hand or manually. So initially we tried to have subject access reviews. And if you have a dashboard with 10 panels and 3 namespaces per query, that's 30 requests or 30 subject access reviews for one dashboard. That is quite inefficient, especially because the Kubernetes API will throttle you after around 5 requests. So your dashboard load times will increase. So we opted to just get all of the roles, role bindings, cluster roles, etc., and resolve it ourselves and iterate through them. And that's how we achieved from 6 minutes runtime with the subject access reviews, if you gather all of them, to 1.4 seconds. Thank you for your attention. Are there any questions?
So how would you like to get rid of the observatorium and the primary proxy dependencies? What would be the alternative?
I mean, the problem primarily is that there is currently nothing for Tempo that parses these things, but Grafana Tempo is open source and has already this YAC definition, so we can more or less retrieve that YAC definition and write our parser, and it would be, in my eyes, very friendly to have them in a similar way built, so there are not different type of ways how you enforce for a Prometheus query, for a Thanos query, or for a Tempo query.
Is Multena open source?
Yes,
Awesome.
of course.
So did DeepL state why they are interested in Multena?
Because they have the same multi-tenant issue for their clusters, more or less. They have various amounts of Tempo deployments and Loki deployments, but yeah. Okay.
Awesome.
Thank you.
Thanks. So, quick bio break. Please don't go to the fridge. No, if you want to drink, go to the